I will tell you about our sensors that will help us all throw out less food. My name is Schnorr, and together with our team at the Swagger Laboratory, we are getting that technology ready for launch of our startup in the course of this year. So a week ago, I decided to live healthy. So I went to Star Market, bought myself a few tomatoes, and when I checked last night, they were ready to be thrown out, so I had to go back and buy a burger somewhere else. And unfortunately, I'm not the only one who throws out good food. In fact, there's a recent European Union study where they determined that 89 million tons of food per year get wasted, and a large portion of that is obviously produce. If you look at produce in the US, it's estimated that between 8 and 15% of it are lost, have to be thrown out due to spoilage. So of course it makes a lot of sense to think about spoilage and the ripening process until there to help solve that problem. One key compound for fruit ripening is a small molecule called ethylene. So ethylene is given off by produce while it's ripening, and when produce is exposed to ethylene, the ethylene induces ripening. So people exploit that where they plug bananas green, expose them to ethylene in ethylene ripening rooms, and then get them exactly to the stage you want to buy the banana at a supermarket. But you can also remove ethylene to extend the shelf life of produce. There you see an ethylene scrubber that extends the shelf life by several days just by removing that molecule. But even these little green eggs that you can buy at Whole Foods, other supermarkets, they're intended for household use to make your apple, your banana last a few days longer. So it's really recognized that ethylene plays an important role. The issue is that there are no good sensors to measure ethylene. How important that is, if you think about your thermostat at home, most of you might have one like the one on the left side, but if you didn't have a temperature sensor in your thermostat, it would look like the one on the right. You couldn't set the temperature, you couldn't monitor the temperature, it's just heat or cool or turning it off, and of course that's a big issue. So if we had good ethylene sensors, we could use them for a variety of things in the food sector. You could have a combination of an ethylene monitor and the current scrubber technology. So you could determine, is a scrubber I bought powerful enough for my storage facility? Is it actually working? Does it need maintenance, or do I have to replace something? You can imagine an ethylene monitor in one of the 1 million refrigerated shipping containers that are around, so you know before your shipment arrives how ripe your produce is. You can use a sensor when you receive produce, for example at a supermarket, to determine, okay, this is going to last a few more days. You can put it out on display, and this shipment I better reject because it's going to spoil on my shelves. And you can have an ethylene alarm. Some products like flowers are very sensitive to ethylene, so you want to be notified when the ethylene level spikes before your flowers have to be thrown out. People have recognized that and are working on ethylene detection methods, but the problem is that most current methods are fairly expensive. These electrochemical sensors, for example, still cost close to $1,000, and that's way too much for distributed sensing for most applications, so we need better sensors. So we thought about doing something simple, and all our sensors need are 2 electrodes. You put our sensing material between these electrodes, you apply a voltage, and you measure the current. When ethylene is present, the current changes, so you can determine how much ethylene is around. Here on the top, you see one of our current sensor chips. It contains 16 different sensors. It can be some for ethylene, some for other compounds, and all you have to do with that chip is add some of the currently commercial electronics to do the data workup, to transmit it wirelessly, to connect it to a cloud service, for example. And with that, you can translate the chemical information to an electrical signal and make recommendations. So our technology is centered around 2 big pieces. One is the sensing material itself. We have developed something, a mix of carbon nanotubes and a selector to detect ethylene, and we are developing other mixtures for carbon dioxide, for example, or ammonia. The other part is a fabrication method. We can just put down electrodes on paper, compress our sensor material into a pencil lead and then just draw between these electrodes, and we already have our sensor. That's really simple. You don't need any toxic solvents. The pencil is going to last forever. Think about picking up a pencil from a shelf. It's just going to write, no problem. If you do that with the Sharpie, it might have dried out. So there's a real advantage in making these sensors in this way. So with that, we have sensors that are important for a huge industry. These sensors are inexpensive to make. They are small. They are simple to produce. And on one chip, you can have multiple sensors for different analytes or the same analyte for extra redundancy. But it's more than just ethylene. By developing other selector molecules, you can detect all kinds of gases just by bringing your sensor in proximity of what you want to detect. Of course, the food industry is very, very interesting for us, but you can also think about safety detecting toxic chemicals in chemical plants or environmental monitoring. People are concerned about compounds like benzene that are very toxic near refineries or gas stations. And with our method, you can do rapid prototyping to develop these sensing materials. You can form these arrays very easily. You can even customize your sensors so that one customer gets the safety type of sensor, one gets the one for environmental monitoring. So we see huge applications even beyond the ethylene that we'll start with. So with that, I'd like to thank you and hope to talk with you at our poster.